then. So, well, I must acknowledge Murdoch University is situated in the lands of Binjureb Nuer people. So, yeah, I need to acknowledge this. My presentation is gonna take place representing an assemble of researchers from Murdoch University and around the world. And it's going to be a quick talk about the Beco It's a very widespread group in Australia. So my presentation is divided into four parts. So the first one is why I chose Australia to be the place of work and why I'm choosing the Australian species. Why the Orbian Weaver spider family aranate, speak a little bit about the international collaboration we're doing, and a quick look into our project. Okay, so why did I decide to work in Australia? One could think about the beaches. Well, sometimes it is, but most importantly, because of the remarkable spider fauna that's only found in Australia, especially due to the specific biogeography of Australia with high endemism of species. Of course, there are some that have Gondwana affinities and others that came from Asia, but the most remarkable species are the ones from Australia. The endemism is so high and the species are so remarkable. So why did they decide to work with the Orbian with the spider family Aranate? It's a very widespread spider family and one of the most specious families too, with 178 genera and 3,084 species by 5 December 2021. And they are very large, conspicuous, easy to identify, and they are studied in many ways. So one of these ways is behavior, evolution, as for example, sexual size dimorphism, which we have been also analyzing during this project, material science, and pharmacology. So just to make an example of this, about behavior, we have this paper here from 2018 that analyzed the construction of webs being affected by urbanization. About evolution, sexual size dimorphism in 2000, Hormiga and collaborators proposed a phylogeny of weavers that presented sexual size dimorphism. About material science, uh, this paper here, they analyzed how tough the silk of a spider or weaver can be. Or pharmacology, for example, the presence of toxins associated to webs. So the RNA family also presents a variety of lifestyles and abdominal shapes, which is very intriguing and fascinates me. So for example, here we have tails, scorpion tails, RNAs, you have spiny ones, um, others can wrap around tree barks and camouflage. Another spiny ones, sorry, and others with only hairy abdomen. Also, the construction of web is very intriguing. So you have the orb web, which is the classical web. You have modified orb webs like Sartophora, and you have species that simply don't make a web and use other strategies of catching prey with silk. But of course, it's not the only group. The RNAs are not the only group that produce an orb web. For example, you have tetragonites, which produce horizontal orb webs, but vertical orb webs are classical from RNAs. Uh, Synapomorphies for the family RNA are not very clear still, but they are very easy to identify by the eyes and also because of the abdomen that goes up to the carapace. So you can easily identify this group by some classical uh, classical ways. About pedipalp morphology, it's very clear that the aronades have a very different pedipalp in comparison with other spider groups. So here you can see one of the, I'm sorry, our new species, the soca, and the different amount of sclerites that are present in the ped pulp. So you can see, for example, the radix, you have the median apophysis, terminal apophysis, etc. While in the tetragonata and in a tarantula, you can't see this. So you have the embolus, but you don't have this amount of different sclerites. So here is just a quick look on how the sclerites are named and the female genitalia. So you have many different sclerites there. It's very unclear because no one has ever studied on how the sclerites they act during mating, but it's speculated that the sclerites may lock into the female's genitalia and get expanded on so sperm can be transferred to the female. So during mating, the pedipalp gets expanded and gets in a very different shape, you know. So hemolymph can go into the sclerites, the pedipalp is going to be expanded, and the embolus is going to be inserted into the female genitalia. So it's very different in conformation, and it's very intriguing too. Here, just to take a look on how female genitalia can be shaped in different species and genera. So we have, for example, Eriophora with a very long scape, while in other genera you have like thicker scapes and shorter. So it's very important to analyze genitalia in these groups to identify species and genera. So due to the pandemic, we have to act differently from what would be expected from work of this kind. And it's this work is an international collaboration between Australian scientists and scientists from around the world. So we are led by Volker Frameno from Murdoch University, and our team is composed of Nikolai Scharf from here, where I'm presenting Copenhagen, Dimitar Dimitrov, who works from Norway, Henry Batista, who works from Brazil, and Corvink from New Zealand. And this study is financed by an ABRS grant to Volker Frameno. And I'm acting as a postdoc for this grant. So the traditional way would be to do the phylogenetic analysis first, so we could identify the groups to be revised, described, and to do taxonomy after that. So, but COVID unfortunately jeopardized our initial approach of the project. Still, I couldn't travel to Australia to develop the framework of the project. So I'm still stuck here in Europe, and we had to go the other way around. So we are doing the taxonomy first for our posteriori phylogenetic analysis. So currently we are working on general revisions, species revisions, description of species too, to produce as much as information as you can and to develop phylogenetic analysis afterwards. So the phylogenetic analysis that we're planning to do will be important to homologize sclerites and to understand a little bit more of morphology too. Okay, so unfortunately we had to go the other way around for this project. So the main objective of this talk is to present the group of the backbook games. And so let's sneak into our project a little bit. So the start point from this project was the phylogeny of Scharf et al. 2020 that presented the backbookings to us and confirmed that traditional aranate, which is the traditional subfamily of araneids, was paraphyletic or polyphyletic, with many classical lineages spread over different clades. So we have many aranales that were presented into different clades, like inside the backbookings. So we intend to propose a new subfamily to harbor this new and related genera. So, and to harbor these species that are wrongly placed into Eriophora, Aroneus, and Paravixa, as you can see here. So it's easily observed that the type species of Eriophora is in another position. So it's here in the Eriophorines, while some of the other species are into the Bacobucines. So we described this as new genera. So about synapomorphies of the Bacobucines, they are very unclear still, but the male pedipalp presents an arch over the radix and a single microseta on patella. And here, the type species of Eriophora, for example, the arch is absent. However, you have some species within the Bacobucines that reverted. So we have 2 or 3 species that have 2 microseta instead of only 1, and at least one genus that doesn't have an arch, but has this single seta on patella. So just to have a quick look on our original objectives. So you can see that originally our intention was to diagnose and describe a new subfamily, the Bacobucines, based on morphological and multi-gene molecular data. So this had to go to the bottom of the line because of the pandemic. Then we proposed to diagnose and describe all genera within the Bacobucines, and it's currently what we are doing right now because of this, okay? And afterwards, we intend to develop a multi-gene molecular phylogeny to understand the position of these species and genera. So far, the Bacobucines have 6 revised genera, okay? 3 of them we did during 2021, okay? And these 2, the last 2, the Orthoptera and the Socca, were described this year. So before the beginning of this work, we had 4 species for Bacobucia, 1 for Larioniophora, and 22 for Plebs. Additionally, we have another 2 for Novaciala, 13, including 5 new for Tofra and 9 new for Socca. This one is currently accepted, so we're only expecting this to be published very soon. So that's it, these 3 during this year. For the future, we intend to describe at least 7 genera, including 2 previously described and 5 new. These 2 have been studied during 2021 too, and we still need to submit until the 31st of December. So just to have a quick look on who are the Bacobucines, these 3 are from the published paper before the beginning of this work. So we have the Bacobucia, the Plebs, and the Larioniophora. Currently, we described the Orthoptera, the Socca, and we are sending for publication till 31st of December, the Salsa. So they are conspicuous and a large body species and genera.
Pedro, I'm so sorry. We're going to have to move on.
Okay, I just have another one. Yeah, just one other. Yeah, and that's it.
Really quick.
Okay, yeah. So just to say that the Bacobucines are a very special group and the most common group in Australia. So they're easily collected. They're common in all collections, and surely everybody in Australia has seen one. So I'd like to thank everybody who is watching me. I'm sorry for the confusion between screens. It's the first time I'm using Zoom for a presentation, so I beg your pardon about this. And I must say that I thank EBRS for financing this project and our assembled cast of researchers that accepted to work with me. So I thank you.
Thanks so much, Pedro. I'm sorry to have to cut you off, and the next speaker is me, so it's a little even more awkward. But I I better move on to